Hello everyone, welcome to the Maruti classes. Today we are starting our first lecture of class 8 mathematics rational number. So without wasting time, let's start our chapter number 1. So here as you can see the PDF or your book, the page number 1, the introductory part. Here when we learn it, we observe some specific terminologies like the natural number, whole number, and integer number, positive and negative integer number, and the rational number. So let let us learn about this terminology firstly, then we are moving forward. Otherwise, it is cumbersome for us to learn these things. So here that we are starting with the one line definition of natural number, whole number, integer number, and the rational number. Here the natural number, as we can see on the screen, natural number, any number which vary from 1 to infinity is natural number. Here for your better clarification, you have to observe this scale. These scales show you some data that I am explaining you in the further another sheet. Here uh, yes, here you can see that what is natural number, what is whole number, and what is integer number. What is integer number? Here you have to firstly learn this scale. Here this is the center of the scale, which is 0. This is 1. In the right hand side of the scale you can see that 1, 2, 3, 4 up to infinity. In the left hand side of the scale you can observe that the data -1, -2, -3 up to minus infinity. Here the value of natural number varies from the right hand side of the 0, that means 1 to infinity. The value of whole number includes 0 and natural number, that means value varies from 0 to infinity. Integer number are classified into two types: positive integer number and negative integer number. That's why the value of positive integer number, we can say that 0 to infinity, and the value of negative integer number we can say that 0 to minus infinity. I think you are able to understand what I'm written in the board. The in the board you are able to simply learn, you are able to simply clarify this value, this data. I'm explaining you once more that we have, for the in the chapter of rational number, we have to firstly learn what is the definition of natural number, what is whole number, and what is integer number. Natural number is nothing but the number varies from 1 to infinity is natural number. Whole number is nothing but the value varies from 0 to infinity is whole number, and integer number are classified into two types. Then finally, in the chapter of rational number, what is rational number? So the one line definition of the rational number is any number is, we can say that any number which can be written in p by q format is called the rational number. Any number, for example 2 by 3 minus 4 by 7, etc. Any number. These values represent the rational number. Now we have to move forward to our book. Here we can see that yes, here in the introductory part there were some examples were given. This is the example number 1, x plus 2 is equal to 13. Then what is the value of x? Here we are putting the value of x as the natural number. In the example number 2, the x plus 5 is equal to 5. Then what is the value of x? Here we are putting the value of x as the whole number. Further we are moving that x plus 18 is equal to 5. Then what is the value of x? Here we are putting the value of x as the negative integer number. minus 13, then we are getting the result as 5. So these were the basic examples for the natural number, for the classic, for the clarification or for the revision of natural number, whole number and integer number, which were studied by you in your previous classes for like a class of 4, say 5, 6, 7. Might be possible you have learned this. So they were try to revise them in the introductory part. And then further they were going to the rational number. The example of rational number as the 3 by 2 and the minus 7 by 5. I am earlier said you that any number which can be written in p by q format are called the rational numbers. So they were written in 3 by 2 and minus 7 by 5 as in p by q format. Further, we are moving to the properties of rational number. Look at the properties of rational number. Here I am teach you by pen and paper. Then you can better understand what I am trying to teach you, the properties of the rational number. So yes, going to the next page. Properties of rational number. There were basically seven properties of rational number. Many of them were important and some were then less important. Let we are learn one by one every properties, because in your exam might be possible your teacher asks in the exam is the proper what is that property. So you have to learn every property. The first property is the closure property. Second property is your commutative property. Third one is associative property. These all are written in your book. I am also learned your current chapter book in current chapter. Distributive property. Fifth one is your identity property. Sixth one is your zero property of zero. Seventh one is your number line property. Okay, guys. So here the closure property, here some values, some further classification of this property are, they were classified them in the whole number, integer number, rational number, might be natural number. So if you are not understanding 100% about the whole number, integral number and rational number, then you are not able to clarify the properties of rational number. So that's why I'm teaching you these data, these definitions earlier, then we are going forward to the properties of rational number. Okay, so let's start properties one by one. Okay, so the closure here, the properties of rational number was further classified into the whole number. Here the whole number, here you can see that the remarks section, the subtraction and division are not closed under division. What they actually try to ask us that 0 plus 5 is equal to 5 and 5 plus 0 is equals to 5. Whole number are closed under addition. But in subtraction, in case of subtraction, minus 7 plus 5 can't be the same value, which is 5 minus 7 is equal to minus 2, but 7 minus 5 is a different value. 2. The result is 2. Minus 2 doesn't equal to 2. That's why whole number are not closed under subtraction. So when we observed the here the check for the closure property and the all four properties for the natural number, here we are moving forward. In the case of integer number, we are also that we are observing the division. Here when we add minus 6 plus 5 or minus 7 plus minus 5, or we add minus 5 minus 7, their result were the same, so they were closed under addition. We have to change their place, nothing much more than that. And further, these are the rational number. These examples were further classifying. I'm explaining you but here I am only teach the exact properties of this. Here we can see that the commutative property is nothing but here also the order of the number change, but the result should remain constant. If we change the order but the result remain constant, then it justify the property. Just like in the closure property, whole number, the subtraction and division are not cooperating with the property. Similarly here also subtraction and division are not commutative. Further, we are moving forward that in integer property, subtraction and division are not commutative. Here, here I am not explaining you because here it is very simple that when we observe 5 minus 3, the value comes, it doesn't equal to the value minus 3 minus 5. I am explaining you in the example. Firstly, you have to just learn the properties. Here also we can see that the further associative property. What is associative property? Here you have to remember that the associative property is nothing but the group of number doesn't affect by addition or subtraction. Associative property says the group of number doesn't affect by addition or subtraction. Addition or multiplication. Here the subtraction is not associative, division is not associative, because the group of number are not remain constant when we change the position of the digits in the case of subtraction or in the case of division. That's why they were not associated. Similarly, in case of integers, subtraction and division are not associative. When we changing their position, the group of number were changed, then they were not become associative. Similar cases we are observed in the rational number also, multiplication also. Here a simple graph were given where they were saying that which one is following the particular rule or which one is not following the particular rule, and further examples were given. We are learning the examples further. Okay, so now let's further we are going to the distributive property. What is distributive property? Distributive property, multiplication distributes over addition or subtraction. What does it mean? It means simply they were trying to ask that we multiply any number. For example, uh, uh, here you can see that a is multiplied by b plus c. Here a is multiplied by b and here a is also multiplied by c. So it is the distribution of multiplication over addition and subtraction. This is the example of that. Here a better classification were given. Each and every term summary, as a summary they were given. You have to just learn it and you are able to clarify. Okay guys, and further the rational number 0, the I am also explaining, I am also writing you the property of 0. Here the 0, the value of 0, the addition of 0 or the multiplication of 0, we are observing that the effect of the addition of 0, if it affect our result or it not affect our result. The rational number 1 in the multiplicative identity, if we multiply the number by 1, then the result become unaffected. So that's why they were explaining this, the multiplicative identity, but they were not explaining but they were not but they were not complying the property of rational number when we are adding, subtracting or dividing by 1. It is only identity by multiplicative, because when we now multiply any number by 1, then the result will become 1. Same. I mean to say the result will be same. The multiplication of 1 doesn't affect the result. Okay guys, so we are further learning the examples on the further lecture, but today I think the theory portion were completed. So thank you everyone.